The table at left shows the percent of the population of Belize, age 15 to 49, that had HIV. Let P be the percent of the population of Belize, age 15 to 49 with HIV, at T years after 1990. Now we're going to be asked to do something with this information. So once we've had a chance to look all of this through, let's just see what we're going to be asked to do here. So we're going to create a scattergram of the data and draw a line that comes close to the points in the scattergram. We're going to use our model to predict when the percent of the Belize population age 15 to 49 with HIV would reach 2%. And finally, we're going to use our model to estimate the percent of the population of Belize age 15 to 49 with HIV in 1995. Okay, so let's see how they've given us all the information we're going to need to work with this. So pay close attention to the words. Don't just jump too quickly to the numbers. Notice here they're telling us what variables to use. Let P be the percent of the population of Belize age 15 to 49 with HIV. And then they're telling us to let T be the years after 1990. So we're not going to actually use the numbers 1990, 1992, 1996, that kind of a thing. We're going to be considering those years and how many years they are since 1990. So for example, for 1990, that's 0 years since 1990. So that one, T would equal 0. If we were to look at 1996, that's 6 years after 1990. So that one would be T equals 6. And we could quickly fill in the rest of these. There's T equals 2. 1993 would be 3 years later. So T equals 3. 1998 would be T equals 8. And then 2011, that would be 11 years after. So those are going to be the T values we're going to use here. So here's my T values, and here are my P values. So that's going to set up the ordered pairs I'm going to use. But before we can plot any ordered pairs, we need to get our coordinate system set up. And I've already started with that using the information that's given in this paragraph. This part that we marked is the part that is just going to go directly onto our graph. There's the P for the percent of the population. And because that's the second in the second column here, we know that that's our dependent variable. So that's going to go on the vertical axis. There's the P variable on the axis, and the label is already there. Percent of Belize's population, age 15 to 49 with HIV. And then the independent variable here is T, and that's years after 1990. And so that's what we've put down along the independent variable axis, the horizontal axis. There's my T variable there, and years since 1990. So I've got my coordinate system all set up. The last thing I need to do though before I can start plotting points is I want to figure out a scale to use. So let's start with the years and then we'll deal with the percent of the population. So for the years, notice we go from 1990 to 2001. So my T values range from 0 to 11. And so as I look at how many lines I have down here, it makes sense to me that scaling by ones would be just fine. That will use up a lot of the graph. And ones are always good to scale by if we can do that. So let's go ahead and put our scale here for the year. So years since 1990. So we know at the origin it's 0, and we're going to scale by ones, but I'm only going to label every other line. So there's 1, here's 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12. We can go all the way out to 14 there if we wanted to. So I'm scaling by ones, but notice just labeling every other line. Just it's a little bit faster, and I also think it makes the graph a little easier to read. Now on our vertical axis, we want to be a little bit more careful because look at the range of values. Look how small they are. We only go from 0.5 up to 2.2. So if I scale by ones, what's going to happen is that all of my information is going to be like in these first two lines. It's all going to be smushed into a very small space. I'm going to have all this part of my graph that I won't have used. So what we want to do is we want to think about how we might be able to spread this information out to make reading the decimal numbers a little bit easier. So let's see how many lines we have here. We have 2, 4, 6, 8, 10, 12. We have 14 lines to work with. So in those 14 lines, we need to get up to 2.2. Sometimes it can be helpful to think of this without the decimal number. If you think about that, well, I had to get up to 22. Going by twos would be good. If I had from 14 lines, if every line represented two, that would get me up to 28. I would have a little bit of extra space. But instead of going by twos, I'm going to take my decimal point into consideration. I'm going to scale by zero point 0.2, 0.2. Okay, so that's going to give me a nice scale to be able to go by here. So on this is a little bit tricky. Sometimes with these, you're going to have to play around with some different scales to get one that you like. Decimals are always a little bit trickier to work with. So don't be afraid of it. Just be willing to, make some mistakes along the way. And if you do, you just erase it and you come back and you just start all over again. So 0.2, here's 0.4, there's 0.6, here's 0.8. This would be 1 right here. I'm going to go ahead and label that in there just to make that easy to find. Then this is going to be 1.2, 1.4, 1.6, 1.8. Here's going to be 2. Here would be 2.2. Here would be 2.4, 2.6, and 2.8. So there's our scale. Again, the scale with the decimal numbers could be a little bit dicey, but just trust that you can get that if you just take your time with it and just think the problem through. Now we're finally ready to plot our points. So let's go up and see what points we have here. So at 0, we want to plot the point 0, 0.5. So when I'm at 0, let me get, let's just do our points in black here. 0, we're going to be at 0.5. So here's 0.4. 0.6 would be this line here. So 0.5 would be the point right in between. So that's going to be that first point, 0, 0.5. Now we want to plot the point 2, 1. So we can certainly come down and do that one. So here's 2, and here's 1. And sorry for all the scrolling up and down here. The next one is 3, 1.2. So at 3 years, since 1990, the percent is at 1.2. At t equals 6, so 6 years since 1990, we're at 1.6. So it's 6, we're at 1.6. And then at 8, we're at 1.9. 8, we're at 1.9. So 8, there's 1.8, and there's 2, so halfway between would be 1.9. And then the final point that we need to get on our scattergram is 11, 2.2. So here's 11, and we're going to go up to 2.2, which is right there. And we can see this is really close to linear, but it's not quite there. So let's grab our straight edge. So whenever we're asked to draw a line that comes close to the points in the scattergram, be sure you're using your straight edge. And I've got a little electronic straight edge here that I can use. I need to go up and grab it up here. Let's see, I got 2 of them, so let me get rid of one. So let's move this one down here. So I'm going to bring my straight edge down here, and I'm going to line it up with this first point. Oh. And then I'm going to pivot it to line it up so it's, and notice that I wouldn't want to do it so my first and last point line up, because that would put all of my points up above it. I want to kind of split the difference, so some points are above and some points are below. And so I'm going to move this to kind of be about there. And so now notice it goes through this first point. I have a couple of points above the line. Here it goes through another point, and then I've got a couple of points below the line. And so that can kind of help us to see that, yeah, we're sort of splitting the difference here. Now, it could be a little bit lower than this because that point is so much further down that the little bit that these are above the line could compensate for the quite a bit much lower that that one would be below the line. So there's not just like one perfect line that we're able to find at this point in our math career. So just find one that seems to kind of split the difference with all of the points that you've plotted. So I'm going to go ahead and draw my line here. And I want it to extend all the way even past the points that I've plotted. Okay, so there's my line. So let's get rid of the straight edge because we're done with that now. And I want to get my arrow on my graph. We're thinking that this is going to keep going. So I'm going to put my arrow here. But because we're just starting with 1990, we're just going to keep a solid dot right here. We're saying this is our starting point for this. So let's use our model to predict when the percent of the Belize population age 15 to 49 with HIV would reach 2%. So 2% is right here. So we're going to say, when would that be happening? So let's see where that's going to hit my model. So I'm going to be coming over here, and I'm seeing that that hits the model right about there. And then let's see where that's going to actually run into my independent axis down here. So I'm going to come straight down. And I'm coming down here, and I'm going to say, where does that hit? So it hits right there. So coming from 2%, we see where it hits our line, and then we come straight down. And that looks like it's hitting at about 8.5, at about 8.5. Now, what does that 8.5 represent? Well, if you remember, that's years since 1990. So when will the percent of the Belize population, age 15 to 49 with HIV, when would that reach 2%? So sometime it looks like in 1998. Okay, and we could say maybe about halfway through 1998, about halfway. And that accounts for the fact that we're about halfway between the number 8 and the number 9. About halfway through 1998, or sometime in 1998 or during 1998. Lots of different ways that you could state that. Now we want to use our model to estimate the percent of the population of Belize, age 15 to 49 with HIV in 1995. So now they're telling us 1995. And remember, that number we're not going to find along here. We want to be thinking about that 1995 is 5 years after 1990. So we find, here's my 5 right here. So let's see where that's going to hit our line. We go straight up. And then we go straight over. And that's nice because it actually lands right smack dab on a nice little point there. And we're between 1.2 and 1.6, so that must be the number 1.4. So in 1995, we'd estimate that the population, the percent of the population would be at about 1.4%. So with HIV in 1995. And that does all of the things that this problem asked us to do. So we were able to do a lot of work with just a little bit of information from a little short paragraph and a nice little table of data.